So for this session, it's about innovation in math museums and math outreach. So we will have 3 talks. The first one will be from Tim Reinhardt, who comes from Germany, from the Technical University of Munich. And Tim will talk about conformal mapping. Then we will have Siegel from the USA, from the MathHappens Foundation, talking about hang time. And we will finish with Katie Chicot from the UK, from Leeds, from the MathsCity and MathsWorld projects. So we have a bit less than 1 hour and 30 minutes for 3 talks. So it means that you will have 10, 15 minutes each for your presentation. And then we'll try to have between 10 and 15 minutes of exchanges and question and answers with the public for each. So it's your turn, Tim.
Thank you. Hi, I'm Tim. I'm from the Technical University of Munich, and in particular from the working group of Jürgen Richter-Gebert. And I'm here to present some joint work with him and Aaron Montag. And it's about the computation of some certain simple conformal maps. Why are we interested in conformal maps? Take a look at that dynamic version of the conference logo. This basically looks so cool because the animation has at its heart a conformal map. But the conformal maps we are interested in are in their kind a bit different, because in our case, in difference to this animation there, we do not know the certain form of the conformal map, and in particular, our conformal maps may not be expressible in a closed form. Others than these are simple. Our interest in these conformal maps originally comes from hyperbolic symmetry groups. And what the goal of the research group was in particular to transform Euclidean symmetric patterns or ornaments into these hyperbolic ones, as shown there. And if you think about this, this really boils down to the key question: how to transform the fundamental cells of the symmetry. If you haven't heard this term, a fundamental cell is basically a maximal region of a pattern without repetition. So this is really where the artistic content from the ornament comes from. And a clever way how to map these fundamental cells are conformal maps. Why this is the case, I will explain in a minute. But first of all, a quick disclaimer. The working group has been able to do this since around 2009. The problem with the techniques at that time was that they were terribly slow. So to create a picture like this would take up to several minutes. And since then, the goal was to make this fast. And to make this fast, we searched for an algorithm working on the GPU. With the problem that the old algorithm was inherently not parallelizable, so not realizable on the GPU. And I'm here to tell you what we do on the GPU to do this more fast. Just to give you a sneak peek, so to say, this is what we were able to achieve. So this is a quick clip from Jürgen's app iOrnament. Some of you may know it. And giving Escher tiling in this case, so a Euclidean pattern as input, we are nowadays able to transform this to hyperbolic symmetry groups in real time and also really smoothly change the symmetry group in the hyperbolic case. And this really looks super cool because you can kind of feel the map getting more conformal while the pixels swim to the right position, so to say. Yeah, why conformal maps? I'm happy to feature the second graphic of today with a chessboard in it. For the math people, a transformation is called conformal if it preserves angles and orientation. And viewed as a complex map, this is equivalent to the fact that that map is holomorphic and has non-vanishing derivative anywhere in its domain. Now, having computed 3 different maps, mapping this chessboard onto the unit disk in 3 different ways. The middle one is a conformal way, whereas the outer two are not. And the remarkable things about conformal maps is that infinitesimal figures are only rotated and scaled. What does that mean? If one zooms into it, you can see that the knight really still looks like a knight. There's some distortion going on with the rook, but if you would zoom in more closely, the picture would still look like the original one, just rotated and scaled. And this simply means that we can preserve with conformal maps as much creative content of the ornament as possible. So that's why conformal maps are cool. How do we compute them? In theory, we have the Riemann mapping theorem. It states that every simply connected region U, which is not the whole complex plane, is biholomorphically equivalent to the unit disk. This is really surprisingly general because this covers the existence of any conformal map one might wish. But this has the drawback that it's only an existence statement and the proof is not constructive. So this doesn't help us at all, except guaranteeing that we can hope for finding conformal maps. Now, our new approach uses a key idea, namely, we want to use that fact, which I've told you about, that conformal maps are infinitesimal scale rotations. So, considering a small epsilon ball around a point P, a conformal map will approximately map this to another small epsilon ball, which is just a rotated and scaled version of the old one. That means that a necessary condition for a map to be conformal is the following. If you have the situation on the left, where we have a point which is the arithmetic mean or the center of the gray surrounding points, I don't know if you see that the middle one is green. If we apply a conformal map, this property that the middle point is approximately the center of the outer ones is still approximately true. And so the idea for our and every time I draw such an image with these points, you can really think of the points as being pixels, because in the end we want to deform images given as pixel data. So the idea for the algorithm is to start with some mapping and then try to force it to fulfill this property. How do we do this? Given the images of the surrounding neighbors of the point P, we just define the new image point f of P to be exactly the center of the surrounding ones. We do this in a parallelized way on the GPU, so we do this for all points simultaneously at the same time, iterate this process. This works really fast. And another way you can think about this is that if at a given iteration, the old image f of P is not in the center of the surrounding ones, then you can imagine these lines which I've drawn between the points to be rubber bands or force springs. So that our algorithm kind of searches for the energy minimum or equilibrium of the situation, where this gets into an equilibrium state. And in view of this conference, this is really cool because one can use our algorithms to do a couple of nice conformal visualizations, but using this heuristic, we can also make an own exhibit about explaining how we do these graphics. If the world would be infinite, we would be done because every point would have these neighbors and we could do this method and so on. But of course, we cannot compute infinite things, and so we need boundaries. But these pose a problem. Imagine that you want to map the unit disk onto the square. Then, if we zoom into it, the following situation may occur. It may happen that we consider a pixel P, which lies really close to the boundary of the circle, so that it only has 3 neighbors inside of the circle. The problem is we would need a fourth neighbor, x, as indicated there, but this, in this situation, would lie outside of our domain, and therefore our mapping, which is defined in the interior, is not defined there. So this x is kind of a ghost point, but obviously we need some counterpart for x in the image, because f of p heavily depends on this. So to deal with boundaries, we need a way to fix this position f of x. And luckily, so at first this seems impossible to implement, but luckily there's a really simple trick going back to the 19th century, and it's due to Hermann Schwartz, and therefore it's called the Schwartz reflection principle. And what that does is to give an analytical continuation of our map from the interior of the domain to the outside. This restricts our considerations to regions bounded by straight line segments and circular segments, but this is generally enough for our purposes. And how does this work? Given a point x as shown here, we express it as the reflection, circular reflection or line reflection of a point y, which then lies in the interior of the domain. This point y can be mapped because the map is defined in the interior of the domain, giving a point f of y. And then if we simply define f of x to be, again, the reflection of this point f of y, this indeed is an analytical continuation of our map, so that we have the map defined everywhere and can use the principle shown on the slide before to compute the map. So you've seen a first visualization. Let's show you a second demo. Here we mapped some polygon to the unit disk and the unit disk to some quadrilateral. And as you can see, the nice thing about our algorithm is that it is highly dynamic. So as I said, the pixels swim to the right position, but furthermore, as shown in the lower right corner, you can even smoothly adapt the target shape or drag some points to the right positions. And the maps just swim to the right position. And clearly this has applications way beyond hyperbolic symmetry groups. So I hope you like our algorithm and the visualizations as much as we do. Thank you for your attention. I'm looking forward to your questions.
Thank you very much, team. So if you want to ask a question, please raise your hand and I will come with a mic in order to let your question be recorded.
Just a curiosity, so you can use a webcam as input and transform conformally the input of a webcam almost real time?
Yes, certainly.
Wow, I would love to see it. Thank you.
Yeah, actually, that's a cool idea. We have done that before, but not using this algorithm. We will do that.
Yeah, it's indeed what I was thinking, like you can make all the museum, you know, usually paintings are in rectangles, sometimes there are differences, and you can put them in circular shapes, and it's like mathematical museum with all this, I don't know, Mona Lisa, since we're in Paris, and things which go in good shapes, in any shapes. It seems quite amazing. I remember I've seen once a movie. It was just a movie, normal movie, but there was one over that applied to it, just inverted movie. So you had some stuff you see very well the circle, and things which were supposed to go on inside go outside, and vice versa. So maybe there is also some animation to do with I mean, if you have a movie in a rectangle, you can also have a movie in a circle and all these things. Oh, that's nice.
Yeah, cool idea.
Thanks. So just a curiosity, because you were talking about hyperbolic geometry, and one typical model is the unit disk, but we are also in where we are, Henri Poincaré Institute. So did you try with the upper half plane, so with the Poincaré model?
So this hyperbolic ornament there lives in the Poincaré disk, right? Or how do I have to understand your question?
No, don't worry. It's just that the unit disk is one typical model for hyperbolic geometry, but the other one is the upper complex plane.
Yeah.
So usually it's called also Poincaré half plane. So it just
yeah. I think just graphically speaking, so there is some, as you know, some nice conformal map in closed form from the unit disk to the half plane. I just never did that because I thought it wouldn't look cool because everything goes away. But that would be possible as well, yeah.
This mapping there, does this also work for non-convex shapes? Can you map the circle, the disk onto non-convex shapes?
In theory, yes, it should. In our current implementation, we cannot do this because we store it as a polyhedron given by the half planes. But if one would change that and use a more local description of the shapes, I think that should be possible. So Riemann mapping says there has to be the map. So
are there other questions? Yep.
Yeah, two quick questions. One, you said that this is a new algorithm. Can you say something about the old one and why did you change it? And second is if you are not giving an explicit expression of the conformal functions, right? Doesn't matter if you prescribe the target space or the origin space, so you can do both. Is not the problem since you don't have an expression, or can you put an expression there?
So yeah, what we cannot do is to get an expression out of this, because doing this in an iterative way, we only know where the pixels go, but we don't have a mathematical expression for this. And the old algorithm uses this notion of discrete conformality by Bobenko, Springborn, etc. I don't know if you've heard of them. And therefore, one needs to do a convex optimization first, and then has a rollout phase for the layout. And the computation of the convex optimization takes long and no chance to do this real time.
So, are there other questions? No. So, thank you very much, Tim, for your presentations. So now we will have a presentation of Lawrence Siegel from MathHappens Foundation, and the presentation will be about hang time. I remember you that all the presentations are recorded, so you will be able to watch them again in a few days. I think they will be uploaded next week or the week after, in 2 weeks. Yeah. So everything will be on IHP YouTube channel. So it will be open to everybody, even people who didn't attend to the conference. So maybe if you have colleagues that were interested but couldn't come in Paris, you can send them the link when it will be published in a few weeks, in 2 weeks.
It's not your first.
No.
Sorry.
But I'll have to get to that video. How do I do that again?
To the video.
I thought I had to
This is the last. Yes, it was there.
No.
No?
I want the window.
Okay.
Because it'll go to Twitter.
Okay.
And I won't get back.
It's on a link on.
That's Twitter. So, well, you can click on it.
Ah, okay.
And see it makes a window.
It's on Twitter.
Yeah. So,
That's
can
it?
yes, but can you take me back to the
Yes.
presentation?
Oh, okay.
Which is
Okay. And it's this one.
Oh.
Here you are.
Okay. Okay. You'll.
So. So can I put it in full screen? Okay.
It's a very small technical detail, but I'm a little bit nervous.
I'll give you the microphone.
Thank you. Am I okay? Okay. I am Lauren Siegel. I'm director of MathHappens Foundation, and we've been working since 2014 to use the resources of the foundation, that is money that we have, to increase opportunities to learn math in our communities outside of school. Everything outside of school. And we do share everything that we have digital and many of our physical models for free. We don't fundraise, we don't collect money, we don't sell anything. We're interested in how can we spend our money to do the most good. And that is where this context of this talk, hang time, is something that I want to discuss in terms of how we think about impact. How long do people stay engaged in a learning experience? How able and likely are they to share the learning with others? And further, can we share with and inspire other institutions to sponsor or host these kinds of events? We're going to see some examples. But first, our initial concerns as we started the foundation, we were asking the question, why is there little to no math evident in our informal education system? Go to a library, a museum, a zoo, there's no mention of the mathematics that could be talked about in a context where it relates to the topic at hand. The answer to the question is in the bottom right, upside down. And we had a second question, which came out of the proliferation of makerspaces and digital technologies to make things, which is, why don't we have better models? They're not hard to make, and we could easily design and make some. Why don't we? Again, kind of the empty set. We just decided to start and see what we could do. Our first try was a field trip. We wanted to partner with a school teacher who wanted to get her students off campus and see if we could design a mathematics field trip in a nature center. We took some time to design some modules so the students could rotate. The two we're going to look at, one of them involves models and inquiry, and one of them involves doing some work with a paper and pencil. These are very informal photographs, just a walk around, click what's going on in this room, click what's going on in that room, and we didn't look at them until later. Here's one. Here's the other. That first one. Wah, wah, wah. Shoulders slumped, faces down. It's a sad, dark room. So we were convinced these two photographs convinced us that we wanted to focus on models and inquiry and getting up and moving around. So we've tried a lot of different things and a lot of different ways to putting math in our community. Let's take a look at a few. We designed a sculpture, tables, and we put there's a Penrose stair under that tic-tac-toe board. That's a 3. You got your 4x4 subdivided into an 8x8 chess checkers. And then you've got a proof without words. The sum of the odd numbers is the square numbers. This is in the side garden of a historic home, sort of a museum, in Austin. And when they have special events, it looks more like this. And people stay. The hang time is good. They're attracted to it. They don't run away. And we really enjoy the time we spend on there. To be fair, there are cupcakes on the proof without words. So, yes, increase hang time with cupcakes. Let's go on. That, by the way, the tables have been there for 5 years, so they have that kind of hang time too. They're durable, outdoors. This is last weekend. I just came from the Minnesota State Fair. Christopher Danielson runs Math on a Stick. It's 12 days of a very large math playground at the fair. Over 150,000 people come through those fairgrounds. And I brought some math on a stick with these frames. So this is an example of a make and take, where you get to make something and you get to take something home. And in our view, it should be something that you want to keep. Maybe you decide to unstring it and restring it. In the case of the circular one, you could get a different aperture if you change around. Or maybe you just wear it for the day. It has a different kind of hang time because it's a durable thing you take home. This is the MathHappens room. It's hosted in our Nature and Science Center run by the City Parks District. It's in that same facility, actually, and it might even be that sad, gloomy room, but we've put some different things in it. And it's open every weekend. It's free. It's 9 to 3 and 12 to 3 on Sundays. It's a different way that we can offer some hang time. We have kids stay for 2 hours. Their parents want to leave, and they can't. Now, again, to be fair, this summer it's been over 104 degrees, so sometimes they go outside and then they come right back. So, air conditioning. I want to show you this video, and I want to just say a word. We also stay out of the digital space. We decided no paper pencil. We're just not going to do it. There's plenty of paper pencil in the world. And we also decided to stay away from video screens. But this is a physical model, and I'll have it in the bazaar area. But, okay, now help. I just want you to see this because it's actually a tweet. Professor Kontorovich got this model in the mail for me and did that. That's it. And 105,000 people looked at it. It hopped from Twitter to Reddit to all kinds of other platforms. It's just a little bit of wood, but it explains a murky concept really well, and you get it quickly. You know, when I was teaching, we had this myth that you should struggle through and, you know, tear your hair out and try, or sometimes you can just interact with a model and get an understanding that helps you then move on. Yeah. So that was the digital world hang time. Moving on. This is I'm calling it a reference model, and I think that this is one of the most interesting things that happened. About a year ago, we wanted to buy one of these, and we couldn't find one. So I just sat down and designed this with our software, figured out how to make those parts. And this is made in a makerspace. It costs us about $10 to make. And as a foundation that's looking for ways to spread more math knowledge and math happiness, we've decided that we will just make a lot of them. And so far we've made over 3,500. We've sent them all over the world. It's a little annoying to make it for $10 and send it for 40, so we don't always do that. We look for partners. Every time we're looking for a partner. MMACA has been our partner here. We've recently made contact with a fab lab in Berlin who just made us a sample, which I should have available for you to see at our table. And this is another kind of hang time, I think, something that's just universally wanted. They hit the classrooms this fall, and I hope that enthusiasm for this model will spread to, well, I want some other models. We all have maker spaces in our communities and at our academic institutions. Have we invited ourselves as math people into those spaces to see if we can make something meaningful for us and our students? Which one do we focus on? That's really our question. Now, we have so many different ways. Do we put permanent installations in various places, more take-home projects, more field trips, more demonstration models? Do we think about these rooms that can be, small enough and inexpensive enough that they can go to the small towns, spread around our state where there's very little access? I want to invite you to give me advice on what you think is the most important, but I also have one more demonstration that I would like to give to you and share with you before we take questions. On the left is my email address. On the right is our web address. This demonstration will not take long, and to our previous speaker's point, it has been practiced a number of times in a number of contexts. So I have a high confidence that it's going to go well, but we'll see. These are very simple things that you need. You need at least one of these, bottle with something colored in it, and at least one of these, bottle of clear liquid. There actually are more. These are optional. These are blindfolds. And you need 2 volunteers. Can I have 2 volunteers? Okay. I need 1 more volunteer. Yay. So I think we're going to use the end of the table. You need a chair too. Okay. So, neither of you is colorblind. This looks different from that? Yes. Excellent. You qualify. All right. Have a seat. Blindfold. 1 for you. Okay, we're almost ready. You don't have to be blind yet. It's coming soon. Okay, these are cups. Do you agree? Okay, all set then. Uh-oh. I feel like I just took somebody's water. It's okay. Nobody's drinking anything. We're just going to look. All right. So, you, yes, and you'll just have to listen and nod if you understand. Okay. Okay. I am going to put 3 bottles behind this cardboard shield. And I'm going to take what is in the bottles and pour it into the cups in a certain way. All right? And it's going to be your job to tell me what's in the bottles. Okay? Yes. Oh.
Yes. Yes.
I learned that last time I did this. I didn't give the microphone to my helpers. All right. This is bottle number 1. The cups are A and B. Okay. You have cup A. You have cup B. It's closest to you. Okay, bottle 1 into cup A. Bottle 2. Bottle 2 into cup A. Bottle 2 into cup B. Bottle 3 into cup B. All right. Bottle 1 went into cup A. Bottle 2 went into cup A and also into cup B. Bottle 3 into cup B. Okay, take off your blindfolds. Okay, so cup A. What can cup A tell us about what's in the bottles? Okay, that you're pretty sure. Yeah. Can't see it. Okay. Okay. Now we're overthinking. What do you say about what can you say? What's in Okay. No, I used 3 bottles. I have at least 1 white and at least 1 red, but more, maybe more of each. So okay, so what is in bottle number 1? Who knows that for sure? If you could only look at your cup. You don't know anything about bottle 1, right? No. What do you know?
That bottle 2 and bottle 3 have clear water.
And what do you know?
I also think that bottle 1 and bottle 2 have clear water.
Okay, so together, you're sure that they're all clear. Let's check it out. Wow, yay! Okay, this is some good thinking, though. Good deductive reasoning. Now, you're an unpaid intern in this, right? But if you were an expert with some experience, which you kind of are now, maybe I have to pay you 100 euros to analyze this cup. And I have to pay you 100 euros to analyze this cup. But you analyzed 3 bottles. So instead of 300 euros, I got my answer for 200 euros. So thank you. Saved me 100 euros. Are you ready to go again, now that you know what you're doing? Okay. Okay, I'm going to speed this up. Bottle number 1 goes into cup A. Bottle number 2 goes into cup A and cup B. And bottle number 3 goes in to cup B. Okay, now just hold on and wait. Okay, person, go ahead, take off your blindfold. What can you tell me about the bottles?
At least one of the first 2 bottles has colored water.
So 1 or 2?
1 or 2, yes.
Okay. What can you tell me about the bottles?
Bottle 2 and bottle 3 have clear water. And if I know what she said, I'm allowed to hear what she said.
So together, what do you say?
Bottle 1 has wet water.
Are you sure? No way it could be something else.
I'm sure bottle 1 has colored water.
I am almost sure. There could be, like if your colored water has a different density than the clear water, there could be something else.
An overly educated answer, but yeah. Okay. All right. Yay! Saved me another, I just saved another 100 euros, right? Maybe your price is going up as your experience increases. All right, you ready to go one more time? Just one more. Expert now. So now it's 200 euros per cup each. Oh. Okay, same thing. Well, hang on. Well, it'll be fine. Ready? Bottle number 1, cup A. Bottle number 2, cup A. Bottle number 2, cup B. Bottle number 3, cup B. I guess you're going to hear what each other says anyway, so go ahead and take off the blindfolds.
So now we have several options. Either all 3 bottles have colored water, or the second. Either all 3 bottles have colored water, or only bottle 2 has colored water, or bottle 2 and another one of the other bottles has colored water, I think.
Or one other option you didn't say, 1 and 3 have colored water and 2 is clear water.
Oh, okay, very nice. So now I'm uncertain. I've already used up 400 euros now, analyzing these cups to say they have something in them. Now I have to go back. Let's stay with 100 though. Spent 200, and now I have to go back to all 3 bottles and test each one by looking at them. And now I've got to spend another 300 euros. Now I have to spend 500 euros to analyze 3 bottles. Is there anything else I could do before I go spend 500 euros? Audience, what else could they do?
You should start with the second, because if this one is clear, it means that the 2 other are colored.
Right. So then I've broken even instead on my cost, right? And that would help you out in this situation. So what you've just figured out how to do is called pool testing. And it was invented in the 40s by an American economist. He was solving a public health problem with a mathematical technique, which is to combine samples and test the group. Now, if I have 100 samples and only 2 of them have red in them, I'm going to save a lot, even with this 3 for the price of 2 technique. There are many, many other ways you can do this, but what you've just figured out is a simple version of a complicated technique. There's the simple technique. It was used again in the AIDS crisis when they were analyzing the blood supply. And then during COVID, this is how we get massive amounts of testing done for less money. It was a fascinating experience to read about all the different techniques. I think the Israelis and the Germans had fancy robots to do this. In Rwanda, they were using templates, cardboard templates, to help guide the combinations. Anyway, it's a demonstration that has worked for us with middle schoolers and at something called Nerd Night. It's an evening event. And I would offer it up to you as something fun. I hope you enjoyed it, and I'm happy to have comments on that. Thank you so much. I have a little gift for you at the bazaar if you come see me and tell me you owe me a gift. Yes, thank you. Am I way over time? I'll just cede the floor.
So thank you very much, Lauren. We would just take 2 questions because we need to allow Katie Chicot just after to have enough time. So I think 2 questions is okay. So we have the first one here.
Thank you so much, Lauren. Great presentation. Related to what you were asking about of what do we focus on, and I think some comments that were made earlier today of without doing data analysis, how do you know if your math festival was successful? And I think that is what all of us who are math outreach practitioners are always struggling with. And I guess one guideline that I give myself sometimes is, am I working towards something that would be as popular as Pokemon Go? And that's really what you want, that not only do they choose to do something at a museum, and maybe a particular exhibit or 2 are the most popular within an exhibit, but do they choose to independently do it on their own when they're at home?
Right. Same way, any museum, you're free to go. And the thing that you're spending is your Saturday and your time with your family. And so if we create something that people want to stay at versus go to the water park, go to the next exhibit, do something else, I feel like that's a success. It's a challenge now to try to compare the successes and figure out where to focus. But it's an enjoyable problem to have. Thank you.
So we have time for another question. And if Katie Chicot wants to go to the chair to start to prepare the presentation. So, okay, you're fine.
Yeah.
So we have time
apologies for going over. Thank you.
We have time for another question. If there is one. So there's not. So thank you very much, Lauren, for your presentation and for the little experiments. It was very nice to have it and to take time for this. So we will let you take your stuff, and I will give so the scene to Katie Chicot, who comes from the UK, and Katie. We'll talk about MathsCity at MathsWorld projects. So in just a few minutes. And then after Katie's presentation, we will open the Math Bazaar with a mime performance from Tim and Tanya Chartier. So it will be just after Katie's conference.
Yeah, that's good. Right, you all good? I feel like you should have like a minute of stretching around and, you know, chatting to your neighbour and things so you're not too restless. Right, but you're all good at paying attention. Great. Okay, so my name's Katie Chicot, and I'm a mathematician with the Open University. That's a university in the UK which people can start with no qualifications. So, you know, if school was a disaster or if you've got a job, you can just start and you just come with no qualifications. So it starts at quite a low level and it demands quite a lot of self-direction and motivation. And it's been going for 52 years now, the university. And it's the biggest university in the UK, and I believe we have the biggest maths department in Europe if you do it on the number of students we have, because we just have so many students all around the country. And for me, the Open University, I'm quasi-religious about it. This open access to education, I'm really like fiercely proud and interested in it. But it meant that I was always working remotely. It's a correspondence university, and it meant that I never saw faces. So I did want to see people and do some maths with people. So I've been very involved in outreach, going into schools and going into any public place. I think I worked out that I'd been everywhere except an old folks' home. Because the Open University, they send us into prisons. I've been in maximum security prisons. That's really scary, but you do literally have a captive audience. So, you know, the hang time is great there. But I've never done an old folks' home, so that's on the to-do list. So having done all sorts of outreach, I had always had this thought that I wanted to do a hands-on maths centre. And I got to learn that there were these hands-on math centres all around the world. And then in my country, we have just a really atrocious culture of mathematics. We have one of the worst cultures of mathematics. As you can stop studying maths at 16, and people do, you know, just in droves. So we have, the maths A-level is quite popular amongst A-levels, but there are many, many more people who don't do it, and they stop at 16. So I think we're one of the lowest in the OECD for post-16 rates of maths. So we have this big problem, and MathsWorldUK, the charity that I'm the CEO of, decided to have a cultural solution to a cultural problem. So there are plenty of changes that go on in schools. You change the curriculum, you change the lessons, change some philosophy, but there is no cultural maths space. So we wanted to make a cultural math space, a cultural solution to a cultural problem. And we know it's a cultural problem because if we look at the different ethnicities in the UK, if somebody's grandparents were not born in the UK, they're much more likely to carry on studying maths. So there is, the culture is that it's boring, difficult, and pointless. So people from outside of the UK at the least don't think it's pointless, but they also think they can do it if they try hard. So we wanted a cultural solution. We want to change this mindset. So we want to make a national maths discovery centre. We love the things which go on in MoMath and in MACA and in Mathematicum and the other places we've heard about. And we wanted something like that, but we had to start somewhere. So I'm just going to tell you about MathsCity that we set up, what and where, why and how. I'm now a bit conscious because of Nikki's talk as to whether or not I am showing and then telling. We'll see at the end. Okay, so we've made it a space in a shopping centre. It's about the size of this room. And we have about 35 to 40 hands-on exhibits. So they've been bought from the Matrix community. So we've got something from MoMath here. And well, this was something made by a science centre. And you'll see we've got various things from Mathematicum and then MACA as well. We do have some things that have been made by mathematicians in the UK too. So we started last October. We've passed the 10,000 visitor mark, and we'd like to increase that for a second year. So where are we? We're in a shopping centre, and we decided we had to make a start. We needed to prove ourselves, which I'll come on to, and we needed to, we really wanted to do the work. We didn't just want to talk about the work, we wanted to do it. There's a risk, but we wanted to do it. And so the high street is really struggling. I don't know if this is across the whole world, but in particular in the UK, there are a lot of empty shops. And the landlords don't like their empty shops because they still pay tax on them, so it costs them money to have a shop. But if they have a charity tenant, they don't pay that tax. So it's quite desirable for them to have a charity tenant. So we went to all the landlords in the city until we got a centre that we liked. So we're in here, we're in the Trinity Centre. It's very beautiful, beautiful archway, roof. I should use MathsWorld, you people. Cantilever. And it's very busy, and it's the closest thing to all the public transport, very bustling. It's got the Lego shop, etc. So we were really pleased to be given a space there. So they gave it us rent-free and for 1 year. And like I say, why we decided to make a start, it's a risk because we're showing a small space, so we're not giving the full wow, and we can't really risk underwhelming our audience. We really need to impress the audience. But nevertheless, we needed experience in the field. We needed to go to the funders and say, we can do this. We, as an organisation, it's not just that someone can do it, like in Mathematicum, we can do it. We needed to have some success. And also, with this poor culture, it's very hard to find a fundraiser who can visualise what a Maths Discovery Centre would look like. So we thought we just had to make one, and then they could see it. So the full project is going to be over £4 million. So I think we've all heard today about the difficulty with fundraising, and you know, some people here have got, I'm going to say, Cindy, you're great. Some people have got experience, success. For me, it's one of the most painful activities you could possibly do. I don't like, you know, talking about money, thinking about money, and the idea of going asking for somebody for money is really like unpleasant to me. So we really have to overcome a lot of pain to get this fundraising underway. So at least have a good case under our belt before we do it. So how, once we did get the funds together, and this is just for people who are thinking of doing something similar. If you're not doing something similar, you can tune out for this bit. So once we had raised the funds, we had to decide on the themes, we had to decide on the contents, and we did most of that by going to the community matrix and looking what they had and what was most successful. But we had to go through a branding exercise. You have to, I think some of you have done this for your own activities, something that looks great and can go across all your offering. We had to make a website, we had to make a ticket system, and then we had to get the whole space fitted out in record time with no money. I think by the end of it, our designers just hated us because we'd paid them very little and we gave them no time. Then we had to get staff, and then we had to start our marketing. And we did all that probably over a 9-week period. But the part that was really the most rewarding was recruitment, which I think you might find easy yourselves as well, because there's this massive, enthusiastic community out there of people who want to communicate maths. So we were quite lucky. When we did a general advert, we got nothing. But when we went to the universities, all the PhD students wanted these low-paid Saturday jobs. We've had just excellent, high-quality staff on these super low wages. If we could afford more, we'd pay more. So our staff all have degrees in maths. Most of them have masters, and a lot of them have PhDs, if not lecturers. Yeah, and they add a lot. I'm just going to keep an eye on the time. Yeah, yeah, I've got ages. So as soon as we got set up, we started getting people in and getting people getting photographed properly. We've used some commercial games, some things which are already made. That cuts out a lot of the design process, makes things a lot cheaper. And I've used, you were instrumental in it, Guido, I've used a lot of the Math Spaces research which you talked about, where the part of the point of non-formal learning is to have group work, to have conversation, to have a switch role reversal from teacher and student, so the young person becomes the teacher to the older person, and it's much more fluid. And some of these communal games lend themselves to it more. So we've had our first year, and like I said, we've had over 10,000 visitors, and so we've got to think about our next steps. And the shopping centre have said we can stay for a second year, like second year possibly up to 18 months. So we want to use this time to build our fundraising case, but also develop our contents, which is probably more interesting for this audience. So we've been working on code breaking as a theme. From our other outreach, we know it's a very popular theme, and we have a code breaking expert on our team. And I think you were just talking about maker spaces, Lorian. So what we've done is we've made about 30 prototypes for about £300 each on the theme of code breaking, using local maker spaces. So they're very like rough and ready, and it's to see which are going to be the best ones that can go on to a future centre. These were actually gifts, but we'll just jump past them. We have had one expensive item for code breaking. Sorry, it's blurry. It's because it's a gift. And this is where I think there's some lessons to be learned about the design process and how it is as maths people, and you should perhaps be telling everybody about this, how to work best with designers. These designers were really excellent in how they kept us to a timetable, kept us to a number of decision points where we could feed in. But it was also very difficult because they have no understanding of maths, so they don't know what cool stuff is out there. And people jump to obvious stuff if they don't know about the cool stuff. So we use an external organization for that. But in some ways, I think the makerspace, try it, test it, make something later, will end up being more rewarding. Just to say that code breaking also lent itself to a lot of summer activities, just like the small craft activities, things that can be on the go all the time. So we have lots of like additional little bits and pieces. Crafts works very well. If you've got puzzles, you've got demonstrations, it's nice to have some crafts that kind of blend in. So there's people who enjoy that different kind of activity have got an outlet as well. So this is where people could make their own Caesar wheels and make their own Enigma wheels. And then we've like our code breaking expert has been working on like a hamming trick. It's a kind of a guess your number trick with codes flipping forwards and backwards. Showing hamming spaces, frequency of letters in the alphabet, etc. Right, so I think nobody did talk about their evaluation so far, so I'll spend a little bit of time on this. When we had the Matrix conference in Barcelona, there was a really excellent set of researchers who'd done large-scale evaluation of outreach activities in general in Barcelona, hadn't they? They'd done double-blind trials, there was over 10,000 students, and there were a few take-home messages that they gave the audience. Some of the take-home messages I remember were, you're trying to measure a change, so measure them before and afterwards, don't just measure them afterwards, which, you know, I'd always hated doing the evaluation. I'd always just tested people afterwards, and I knew they were being kind of polite. So we did do a proper evaluation of our first year because we thought that would be good for our fundraisers as well. So we were measuring our success against this. We're aiming to change perceptions of maths. We're aiming to increase enjoyment of maths. We have a whole bunch of other things we want to achieve as well, but that was the big thing we were trying to measure. One of the things we did as a simple like litmus test is describe the experience in 3 words. And so this is the feedback from the students. This is like sort of 13-year-old kids. And we also did do it with adults too, and you get a very similar output. So thank you, Mathematicum, MMaca, and MoMath. Your exhibits were a massive hit. This is what they think about them. It's definitely the overriding message is it is fun. And so for me, MathsCity is like that, letting someone taste the cake. You know, at least know there is a cake out there and it is tasty. Okay, so that's what we've kind of been addressing. Other things? Oh, just smiley faces tell you a lot as well. This is what we actually did. We did, well, as I say we, it was an external organisation. I wanted it to be independent. I didn't want us to colour the output. I wanted it to be, independent. So they did a pre and post survey. We captured feedback on a board. We captured feedback with luggage tags. People tied on their thoughts. A school was observed, and then the observer went to the school and interviewed the students in groups. and then they interviewed the teacher one-to-one. So it's really, they looked at it in every different direction. They really did look at it. And they got decent response numbers. Around 100 people responded. And the sorts of things we saw, so these are some of the things that were nice. Everything can be improved upon. But what was nice was we definitely saw an increase in enjoyment and an increase in maths being a preferred subject. You could separate out the increase in enjoyment. You know, you could see a bigger increase in enjoyment for the groups of students who came who weren't white, which was interesting. And, you know, a slight improvement, slight increase amongst boys versus girls. So we did split out by demographics just to try and check that. Some confidence increase. I don't know if I would say that those numbers, I'd be surprised if they were statistically significant. They're probably not, but there was some increase. This increase is quite good, that the people here who wanted to carry on and study maths at university, that was, that had like gone up. And that is one of our aims, ultimately. The trouble with taking a young person and seeing what impact you've had on them is they take a really long time to grow. You know, you're waiting for years until they do what they're going to do. But we can see some impact. And I don't think we were just looking at politeness here, because I went through all the comments and not everything was polite. So there was definitely a mixture. There were also things which were labelled as areas for improvement. And I think you were saying before about, you know, you notice the criticism more than you notice the praise. Or I think you said you notice the failure more than the success. And that's actually evolutionary. Evolution teaches us to, like, failure is burned in your brain because you never want to fail again. So even though the numbers were much smaller for these areas of improvements, my laser brain was looking at these areas for improvement. So nicely, the biggest thing they said is we want more things. We want a bigger space with more activities in it, which is great. That's what I want as well. That's our whole aim. And they really enjoyed the group work. So as well as some of the games I showed, we also have the MMAC Leonardo Dome is an activity they do after they've had their first hour of free play. And of course, they absolutely love it. And they've never experienced group work in maths. You know, that is totally new. And the teachers are just completely like surprised, and, you know, they're engaged as well. So the group work is a big hit, and we want more of that. More things for groups. And they also said we'd like to have some guidance in advance of coming, so we know what to expect. And we do actually have materials online, so I think some of it's signposting. So there was areas for improvements. I think that might be the most thing I was going to say. So the one thing that I wanted to say here, I've said it a few times, is, you know, we bought our stuff from Matrix. We learned a lot about evaluation from Matrix. We, you know, we've been inspired by the fact that you guys have actually achieved it. The charity was founded in 2013. I came on board in 2019, 18. It all takes a long time, and unless you can believe it's going to happen, it's very hard to keep going. So this community definitely keeps going. So everybody at MathsWorldUK wanted to say a big thank you to you guys, and yeah, thank you for your support, and thank you for having me here today as well.
Thank you very much, Katie, for your presentation. So now it's your turn to ask questions to Katie.
Oh, yeah, we've got 7 minutes. Good.
I'm sorry, tell me if I ask too many questions, but it's hard to get out of habits. So I was very interested by the percentages of people who want to do math, which was very high in the entrance. So I'm asking myself, do you have some idea of what makes people enter and what makes people not enter in the MathsCity, in the commercial center? Do you have something on this? And I want to say thank you for the idea. I think it's super exciting to do math in commercial centers.
So this group of students were brought by their school. So for those people, they aren't people who are already, you know, saying they love maths. So they're like the good test. Whereas I think the general public who come outside of school, usually there's an enthusiastic person about maths. So we see a lot, there's one child who says, my child loves maths, so we're all here today. So at this point, we still feel like we haven't got to the stage of all the people who hate maths, getting them in. So that's definitely like, you know, for the future. So yeah, I think it's somebody loves maths, that's why they come. And the school kids come because the teachers make them come. So I think they're quite good to do tests on as well. It's not free, people pay. Yeah, so that's one of the things about fundraising as well. I mean, there's no such thing as something being free. It's a question of who pays. So the volunteer pays with their time, you know, fine, if that's what you want to do. I mean, and I am like paying my time, but one of the main beneficiaries is the person who visits, so they come in, so they pay. We did do some, this is not the same as your question, we did fundraise for free tickets. So we had, I think, 1,000 free tickets, including 10 free school groups, and then we gave away some family tickets so that we could try and get the hard-to-reach people. We also discovered that if you try and go without the schools, the hard-to-reach people are really hard to reach. You know, they really don't respond. So you really, like, the school is the easiest route to communities, is what we found.
Hi, it's not a question, just a consideration. There are experiences of free exhibition in shop centers. That's starting from Germany, but that arrives in a lot of European countries. So there is an organization that is devoted to this exhibition in the shop centers. And the other one is data before the pandemic. But in the United States, the surface of shop centers is bigger than the one of all the schools put together.
Wow.
So,
yeah,
I know.
It's a new religion.
And of course, matrix is a very big thing.
Yeah.
Hi, that was an excellent talk. I think you showed and told pretty well.
Oh, thank you.
So one question I've had, I guess, for myself and like just in general for a lot of like, I guess the math outreach group is, did you also do evaluation for retention of concepts? Like, did they remember what a bit was or like information afterwards? And I guess this is just a general question of like, what do you think about evaluating for I mean, like obviously like feeling motivation is the biggest like return on investment, like, you know, actually give them a cake being like, here, taste the cake. But I guess, yeah, did we also, what do you think, or like have you evaluated, like, can they actually make a cake from scratch afterwards? Like, did they,
what did they learn?
Yeah, did they remember what they learned? Like a bit, like, you know, what bits are information, code breaking? And like, how does one test that in a way that doesn't feel like school and be like, hey, here's me just testing you. Hope you don't feel too bad about it if you forgot.
So that was actually quite an interesting part of the evaluation talk at the previous Matrix conference, that one of the things you could test is just, you know, like, what do you remember? What's the one thing you learned? What's the one thing you remember? If you're trying to do a snapshot. I don't think what the one thing you remember was one of our questions. We did have a question, did you learn a lot? Did you feel you learned a lot while you were there? And so, you know, that had like a moderate rate of success. But we did find that there was a big response. Oh, we really, and this is not directly answering your question. Oh, we really thought this was science. Perhaps you should call it MathsCity. As if, like, you know, they've seen these things, they've enjoyed them, so they thought it was science. And so one thing I think they should be learning is this is maths. And the whole centre is pure maths. We haven't put any applied maths in there yet. So there was no science in there. It was really surprising. It was all like shape and spatial reasoning and problem solving. And they still said, oh, I think it was science. So our aim wasn't to be a lesson or to be a classroom or to be another version of school. It really is about changing feelings. So it wasn't the main focus of our evaluation, but it would definitely be something we'd be interested in later. And there are sort of maths educational researchers who are starting to come out of the woodwork and wanting to ask things. It's a next steps thing. It's definitely interesting. Thanks.
Thanks, Katie, for the talk. Just one question now, but I got lots for later. But I was wondering about, you mentioned a bit how hard you found to reach out to overlooked communities.
Yeah.
And you mentioned, found as well that schools is the best method, but what else did you try?
Yeah.
What worked and what did not work at all?
Yeah. Well, what we had tried was we were going to community groups. So we had in our minds traveller communities. Then we'd had some communities just in areas of social deprivation, areas where there would be low science capital, you might expect, where there wouldn't be a lot of professionals in that area with science backgrounds. And so we'd approached some refugee community associations, and then mostly community centres in areas of deprivation. We had some community centres where there was like a particular special need associated with it, so it might be like an autism association or something. So what we found was, I think the two problems were, well, COVID didn't help, but I think one of the problems is if you give someone something for free, then I think they perceive it as valueless. It has no value. You've given it them for free. So that's a bit of a barrier. And I've found even if you charge someone a very small amount, it's better. Or you charge them and you give it them back. But the idea that you give something for free doesn't always work in your favour. But yeah, because they were more likely to cancel. The people who paid never cancelled. And the people who we gave things to free cancelled at a reasonably high rate. So that's why when we went through schools who had, they were in real areas of social deprivation, but we just we plugged straight into the kids so we could get them straight away, and then their families as well.
I have a short question related to the first question. When you have, could you tell me something about the sample that you had when you had these percentages, especially on the first one? Yes, on the left one.
Yeah.
No, the other slide. Yes, here on the left one. How big were the samples, or how many? What was the percentage of very good, good, average, not very good, and so on? So because otherwise we don't really know what to do.
Yeah, so there were 163 people in the first survey, and then they got 96 responses to the second survey. So we couldn't do a one-to-one match between an individual's change. So some students who answered the first definitely didn't answer the second.
No, I mean the rows in the first one. So how many were very good, how many were good, how many were not very good, and does this respond? And is this representative actually for the? Because there are some studies about what percentage of school students think they are. I
don't know if you mean for that group. So, for example, 21% is 21% of 163. Don't ask me to do that on my feet.
Okay, this sums up to 100. Okay.
Yeah.
Okay.
Does that make sense?
So the not very good didn't visit the museum.
No, so they all came, but the point was that not all of them will have been available to answer the second questionnaire, or not all of them did. So they tried to catch all the same. So they gave the questionnaire to the pupils before they came, then they visited, and then they sent the questionnaires back to the school, but not everybody replied.
Okay, so. But then it's somehow...
Yeah, so that's why the numbers are there, so it's not pure...
Because it doesn't represent... The population, doesn't it? Does it?
Well, I mean, even the school didn't represent the population. So this was a school. Okay. So this is taken from one school rather than, it's not the same as research. It's evaluation is what I would say, Better than a litmus test, but not up to standards of research.
So we have time for just one more question. And
all right. Yeah, it actually follows suit with this previous question. I was wondering, post-visit is how much time after the visit? Is it right at the exit, or?
It was afterwards. Ruth, was it like 2 weeks afterwards or something?
2 weeks?
I'm going to say 2 weeks, but I don't really remember because they did it for us.
And did the students know that they were being questionnaire from you, or was it sort of, were you trying to fly under the radar to circumvent some halo effect?
No, I think they were reasonably explicit. They were external, so they didn't project their own biases onto it, and this was a written questionnaire anyway, so there was no influence. Yeah. But they knew it was for us. Yeah, they knew it was for us.
Because maybe you can imagine what I'm trying to get at, that when students go back to school, go back to regular math class, how is there a lasting effect of the visit? Or how long does it last?
Yeah, yes. Absolutely. So that isn't something we've tested with this. It was pre, post, and I guess you'd be kind of looking at, you'd need to wait longer. And ideally, we'd want multiple visits as well, so we have a better impact.
Thank you.
Okay.
Thank you very much, Katie, for your presentation, and thank you very much for your questions. So,
I just want to add one thing, which is we had a professional evaluation a number of years ago of some of our exhibits that were at a science fair, so one little booth among many. And the researchers were stunned that it was 3 weeks or a month later that the students were still able to describe what they learned and what they experienced. And they thought it was really surprising because it wasn't just a math exhibit, it was many, many things. And so they thought that was actually surprising and really very favorable. And the other thing, you mentioned the Leonardo Dome, and we have the Leonardo Dome from MACA as well, and all three of us, I think, have the Ring of Fire. And I would just say this is a great community for talking about what things are most compelling to an audience, and maybe there's a way we can do some research on some of the things that we may have in common and share results, because it would be helpful for all of us, I think, to have those results. Cool. So, yeah, thank you.
Excellent.
All right, thank you, Katie.
No, thank you.
So now Cindy will introduce the Math Bazaar and Team Chartier for the next session.